All right, it is 6:30. Good evening, everyone, or I should say good morning to Paul, who is joining us from sunny California. Welcome, Paul. Thanks for joining us, and also welcome, Ernier. Thanks for joining. Welcome to this meetup. This will be all about GraphQL, and it's turned out to be a pretty popular topic, so I'm really happy to see everyone joining in such big numbers. This is actually not the first meetup of this year. We already had a meetup last month around scaling Java development, where I did a talk around how we at Picnic scale our development practices and tooling, and we also had a talk around IDE productivity and improvements. If you missed that, there's a recording at YouTube in the link shown here. So if you're interested in that, I highly recommend checking that out. This meetup will also be recorded, so you can later watch it back or share it with your coworkers. So then in any case, you will be able to access this content later if you want to. So again, really glad that you're here. To set the context a little bit before Ernie kicks off with his talk about GraphQL at Picnic, I want to share a little bit about what Picnic is and what we do, because you might not all be familiar. We're an online groceries company, and if you look at it from the customer perspective, it's actually quite convenient and pretty easy. What you can do is through our mobile app, order groceries for tomorrow or a later time. You can select a time slot that is very precise, much more precise than most delivery services. And when we deliver your groceries, we even have a delivery radar where you can follow our iconic electric vehicles, which if you live in the Netherlands or in Germany, you might have seen already on the roads, and see when your groceries will arrive up to the minute precise. All the while doing this, offering no delivery charges and low prices on our groceries. So all in all, a pretty compelling, let's say, a proposition from a consumer perspective. But if you look at the tech, obviously, there's a lot we need to do to make this work. And then when you think about it, Picnic itself is a quite young company. We started in 2015. And in the years that follow, we had quite a tech journey. We have started with Spring, Java, and we're still on this stack. But incrementally added to the stack with the passing of the years and extending the types of systems that we're building. And if you'd like to read more about that, we have a engineering blog that you can find at blog.picnic.nl, or even better, if you want to help shape the future of this technology stack, then I'd highly encourage you to check out join.picnic.app and see what's possible there. But then at some point there was GraphQL. And it's not very often that a technology comes along that is so challenging the status quo, let's say, because as an industry, we're pretty used to just defaulting to REST APIs and building our systems around that. And GraphQL offers a quite different perspective. So that's why I'm really excited about today's talks. We will have two talks focusing on GraphQL, and the first one will be by Ernier. Ernier is a tech lead in the runner app team of Picnic. So runners are the people driving these iconic electric vehicles that we saw earlier. And this team actually adopted GraphQL, and Ernie will share why and how they did that and what it brought. Then we have Paul, like I said, who is not joining us from the Netherlands, but is joining from California. Originally, Paul is from the Netherlands, and Paul and I go quite a way back. We've worked together for quite a while. But a couple of years ago, he joined Netflix and moved to California. But the good thing about that is that he's now able to share with us the journey that Netflix took towards GraphQL and talk about the DGS library. And I'm pretty sure that he will demystify what the acronym stands for in his talk. So with that, I think we have a pretty nice evening ahead of us. If you have any questions during the talk, I want to ask you to use the Zoom Q&A functionality. So just open the Q&A panel, put in your question, and you can even vote on existing questions that are there. After each talk, we'll have a few minutes and a short amount of time to interact, and I will ask the questions on your behalf to the speaker, and we'll have a short while that we address these questions, and then we move on to the second talk, after which we also have a little bit of Q&A again. So please put all your questions that you have in the Q&A and start voting on them as well, so that we can answer the most highly read questions. And that's it from a practical perspective. I would say have a lot of fun tonight. And Ernier, please enlighten us on what GraphQL at Picnic means.
Thank you, Sander. We'll take it from here. Let me take over here. And thank you all for joining. Very happy to be here and get an opportunity to talk about the technology that one of the technologies that excites me the most these days, GraphQL. But yeah, Sandra already introduced me. I am Ernir, originally from Iceland, here in the Netherlands, and with Picnic for about 3 years now, and I'm very happy about it. But yeah, what I wanted to do today was to talk about GraphQL and particularly how we have been using it at Picnic and how it solved some of the problems that we were facing at the time we adopted it, and a bit about, yes, what it brought us and the methodology that we used to do this adoption. So I don't want to do a GraphQL tutorial or a GraphQL pitch even, but more of our journey, and I want to tell you about the problems that we were facing and that made this the technology for us. But also, I do like to start with the conclusion. So while I still have everyone's attention, there are a few things I would recommend you take away from this. And first of all, I would like to share, I hope you pick up on my enthusiasm for the technology. I think this is great technology. I think it's ready for further adoption almost everywhere. I think it solves a problem which I think will be very familiar to most of the people who are actively working on developing web APIs. And one of the things that they maybe don't tell you in the tutorials, but we found that this technology can be adopted in a very incremental and pragmatic way. So it's not necessarily just something for your next project, but I think you can already start experimenting with it. Well, yeah, Sander already gave an introduction to Picnic and what it is that we do. So we are an app-only supermarket, fastest growing in Europe, fastest growing online supermarket in Europe, I think the code is. We're active in 2 countries at the moment, but something that I really think bears mentioning is that yeah, we are a web shop. There are many web shops, but what we really do, and I don't think anyone else does exactly the way we do, is to leverage technology. I mean, we are a grocery company, but I think it is also very fair to say that we are also a tech company. And yeah, we have a development team of about 150 engineers at this point. I did not look up the number before this talk, but yeah, it's around 150 and growing. And the part that is, well, easiest to see and show is the store app, the app which customers actually interact with and use to buy groceries. But yeah, and we could have a whole talk about that one, but that is not actually where I work. I work on a very different app called the Picnic Runner app. So again, we leverage technology in quite a lot of ways, and we do it throughout the entire supply chain, from making purchase orders with wholesalers to warehousing systems to planning routes to actually delivering it. It is all in-house technology at this point. And the Runner app, as we call it, that is this last part of the supply chain. That is the app that the drivers use. The drivers we call runners. That guides them from this last mile of the delivery. So from picking up groceries in a centralized location, putting it in a rather cute little electric vehicle. If you're in the Netherlands or certain parts of Germany, I'm sure you've seen the vehicle at some point. But the technology that guides us is the Runner app. And that is where I come in. So we actually used to have a third-party solution for this, but around 2018, we developed our own and used the latest and greatest technologies at the time. This is a React Native application. This is running on industrial-grade Android devices, but we developed this in React Native, keeping an eye on the fact that we might one day want to run this somewhere else. And also, this is a direction that Picnic is generally taking when it comes to mobile applications. But that's not it. We call it the Runner team, but we, in addition to the React Native application, we also have a administration page, which is a regular React website. And this is all backed by a set of microservices written in Java. So that is the app, but in order for any of this to make sense, I also want to tell you a bit about the data model. So the main entity that the Runner app is dealing with is a trip. So a trip consists of multiple deliveries. A delivery is something which a customer places in the store app. They add their groceries to a basket and do it maybe a few at a time. And at the end, they place a delivery. And the day before the deliveries are supposed to take place, a planning process runs and generates a trip. And this trip is then assigned to a runner, and the runner follows the plan that we lay out for them in the app. Now, that brings us to APIs. We have trips. We want to show them to runners, and the question comes up: what information do we even need to show to a runner in order for them to perform a trip? Or what information do we even need to know about a trip in general? And this more general question, that becomes a bit hard, because what information you need about a trip, that depends a lot on who you are and who your user actually is. So I pulled a few examples out of a hat. The details are maybe not relevant, but the problem that we found ourselves facing, which might not happen everywhere, is that we have this one model, this one entity. We are dealing with a trip, but there are very many different people interested in it. It's not that just that we have a mobile client and a web client and a TV client or something like that. We actually have different people who are interested in different aspects of a single trip in different contexts. They all have their own needs. They all have their own client applications, and they all have very different requirements. So just to pull one, if we take runner, they need to know a route and information on how to get to a customer. But someone else who is maybe interested in this same trip as a concept, the manager of said runner, they don't really need to know about all of that. But they do need to know whether the trip is actually on time, whether there is something they need to take action on. And another group of people, aside from the runner themselves and their immediate manager, there is also a customer success agent who will likely need to deal with questions from customers. They will need to be able to tell what is in a delivery, was everything correctly placed, is everything on time, but they don't care about routes. So fundamentally, the problem that we were dealing with is that we have this big concept of a trip, but people are actually interested in very, very different parts of it, and there is no real overlapping, there's no real one view we can define for this. So, okay, that's a situation, but I am sure we can find some ways to deal with this, because at the end we just need to build some kind of a web application. And with web applications come APIs. And as Sandra mentioned before, the industry default is to do some kind of a REST API. And there are a bunch of different approaches. Every time I see a REST API, I first need to figure out what exactly is meant by REST in this particular context, because REST means very different things to different people. But in some way, we need to get all of this information about a single entity over to very different clients. And broadly, here are a few approaches you might take. One of the ways you could go about this is that, okay, there is a bunch of information my system knows about a trip, and we can just fetch all of it. We just build one very large endpoint that just is called just /trips, and we add a few query parameters to it, and we just give you all of the information we have. But there are problems with it. I mean, this is how we actually started writing the runner app, but the problem is that this is hugely inefficient. Particularly consider the situation with, let's say, what groceries to deliver. This is an enormous amount of information, but very few clients are actually interested in it. So this is an overfetching problem. We end up querying and requesting way more information from our database than we ever actually need. So this ended up, in particular for us, not scaling, basically. So the next approach we took was to just start writing dedicated endpoints. So each client would have an endpoint that gives all of the information necessary for that client and that client only. But then the problem we end up is duplicated functionality. So we are always dealing with just a trip. But the thing is, even if the payloads are very different, the logic behind them is very similar. So if we were to support all of our clients equally, we would be writing the API 3 times, basically, if we were to do something like that. And with that comes, well, increased maintenance burden and frankly, a whole bunch of boring, poorly generalizable work. So not super happy about that either. We could have gone for a more normalized approach. We could have recognized that a trip actually consists of quite a few things. For example, we have already mentioned that a trip has multiple deliveries. We could have broken it up. We could have broken it up into as many pieces as we want and created a highly generic, flexible API for this. But And this is probably the recommended approach in most cases when you are dealing with complicated client needs. You just provide a normalized API and then work things out later. It's much easier to go from high normalization to low than the other way around. It's same thing as when you're writing SQL. But then you are quite likely to run into performance problems and the problem of actually having pushed the problem of aggregating data just to your client. And finally, related to normalized endpoints, you can augment your normalized APIs with various, let's say, resource embedding technologies. But these are difficult in the general case. If we go all in on resource embedding, then we usually have very complicated clients and usually complicated server implementations, or at least that has been my experience. So none of the solutions that we have were quite satisfactory. And thinking about it, what I really wanted was just for each client to tell me what they want. So if you want certain information about the trip, just tell me that you want it, and the server will send that and only that. And ideally, if I had such a magical technology, this technology would also then pick these relevant parts out of the database and aggregate all of it for me automatically. Well, I had kind of accepted that, well, this kind of thing doesn't exist until I ran into GraphQL. So if you want to be able to allow your clients to tell you what they want, then it sounds a lot like you are in need of some kind of a query language. You need a way for the client to specify what information exactly it is that they want. And GraphQL is pretty much exactly that. It's a query language for APIs. And with every GraphQL implementation comes a runtime, and it takes care of the rather difficult data aggregation problems for you. So all you have to do is then to just define a type system, and then you can focus on the much more interesting problem of executing. Whole lot of plumbing just taken care of for you. And this is, so I say it explicitly, this is the real motivator for us adopting the technology. We started out with having very big denormalized endpoints, ended up having to split them up and doing some duplication just to deal with the performance, and ended up with, well, way more endpoints than we wanted. And then this came along. But just to show you what it looks like, this is what it looks like on our development server. I have a trip there. I just specify its ID, and I just then type in what information I want about it. And there on the right, you can see that the GraphQL server responds with exactly the payload that I requested. And this can be pretty much anything I have defined in the GraphQL schema. And here, if it's a start time of the trip, which some clients are interested in, if it's a status, yeah, it's just there, and it is the responsibility of the GraphQL implementation to actually aggregate this for us. I just need to provide data. Now, those of you who have not played with it, I recommend going to your favorite search engine and searching for public GraphQL APIs. There are plenty of companies that have created open GraphQL APIs. Picnic is not among them yet, but there's plenty for you to play around with. One more thing to point out here is that the shape of the query on the left, this is very much like the shape of the JSON payload to the right, and this is intentional. So just finally, we can just tell the client can just tell us what they want, and GraphQL takes care of the rest. It's amazing. It's magic. Or, you know, almost, sorry, backup slide. It's 2021, but I still never trust that when I put a video in a slide that it actually plays. Moving on. But yeah, I just said that GraphQL is magic, but whenever I pitch GraphQL, I also make very sure to point out that it is actually not magic. We are still dealing with writing a HTTP API. It is nothing more and nothing less. We still have a way to, we are still just dealing with a way to structure HTTP. In regular REST, we do this by defining endpoints, which means defining URLs and doing everything in terms of gets and puts and post requests. With GraphQL, what you do is you basically have everything behind one single endpoint and just post the query to that endpoint, and that endpoint responds with whatever you requested. So again, not actually magic. It's just a really flexible HTTP way, really flexible way to structure a HTTP API. But yeah, this is actually exactly what we wanted in the company. So one of the problems that we were dealing with was that it was difficult to structure an API like this. It was difficult to decide the correct degree of normalization and just the correct information to expose. But with the adoption of GraphQL, that entire class of problems just went away. Now we just make sure that we specify the schema as well as we possibly can and allow the queries to take care of the rest. But that is actually only one part of the problem that we wanted to solve with this, because there was another entirely independent problem that came up, and that is the one of microservices. So Picnic has a whole bunch of technologies, as I mentioned, serving a very wide variety of clients and spread over multiple product teams. So a while back, this entire technology stack was split up into microservices. Usually, each product team is maintaining one or more. And by microservices, in our case, I mean the full thing. They are all running in the same Kubernetes cluster and can efficiently communicate with one another, but these are independent deployments. They have independent databases, and in general, there is a whole fair bit of orchestration that is needed to actually get data in between them. So this is not always a problem at the start, but does tend to grow a bit. But in the beginning, when we started this runner app, we were taking over from a third-party system. But we started out like most applications. We had one client that was the original React Native application. We had one backend service, the trip service, which responded to all requests. And we had one database. And this was nice. We also had one proxy, which we used for authentication. So all requests that are coming in, the authentication was handled by a proxy instead of by the application itself, which allowed a fair bit of decoupling. But in general, the architecture was really rather simple because the app was new. The requirements were small. All of the feature requests had not yet come in. So in the beginning, there was a trip service, but this did not last. This is a actually simplified and abbreviated version of the diagram of the current architecture. Yep, no two ways around it. It is a fair bit of work to actually grok this for the first time. But what is actually rather relevant here for this talk is that the needs quickly arose for our clients to not just interact with the trip service where we started, but they also needed information from other domains, from other services which lived somewhere else in our own cluster. So then the question came up: how do we do this effectively? The first time we needed information from somewhere else, well, the trip service was the backend at first. So what we did was we just did service-to-service requests from the trip service to whatever other service that actually had the information. We had the trip service aggregate the data, and then we sent it on to the client. Well, doing this once or twice is fine, but as it turned out, we were really using the trip service, which was just supposed to be about trips, to do a whole bunch of data aggregation plumbing. So another solution was needed. And then we go back to the computer and stare at it. How should we be dealing with this problem? Well, we could do, if we wanted to do this correctly, a few options. I mean, most of our services, they are actually reachable by our authenticated clients. So what we could have done is to just call them. I mean, they have URLs. There's nothing special. They all have documented APIs. We could just tell our application, okay, if you need some information from some other system, let's say the HR system, if we need to show the user's own name in an application, then we can just call that service, use its REST API. Problem with that is that, we still need to do some aggregation logic, only now we have created all of it in the client. So, and also we now need to stay compatible with multiple versions of multiple systems, and all of this has been pushed into the client, so now the client is unhappy. We can protect the clients from all of that with a rather familiar pattern for, at least for some, that is a backend for front-end pattern. So if you have, let's say, one client and multiple backend microservices, then it's rather convenient to just write a dedicated backend service for the client, which then serves as an aggregation service. Well, that works out rather well. This is actually more like what we do in the customer-facing app. There we have basically only one app, even if it's running on Android and iOS, but they are both contacting the same backend for front-end. This would not really have worked for us in the Runner app because we actually have multiple clients. We need to provide an interface for the Runner app itself. We need to do it for the React administration console, and we need to support the technologies used by the customer success agents. So this kind of an approach, we would have spent a whole lot of time on rather boring plumbing. Not that there's anything wrong with programming plumbing, but it's not really what we wanted to do, just to be able to protect the clients from having to aggregate data. But what we really wanted was more of a flexible backend for frontend. We would like to have just one aggregation layer where any client could just specify their needs, and this flexible backend for front end takes care of the rest. But again, sounds like we need a query language, and again, it exists. This is exactly the same slide as earlier, but this time I would like to draw your attention to something different about this. The second paragraph, a GraphQL service is created by defining types and fields on those types, then providing functions for each field on each type. So when we define a GraphQL schema, we basically need to tell the schema how to resolve each field. And the magical thing about I said magical again. The amazing thing about GraphQL is that how to resolve each field, it is very much left to the developer. So if we take a look at this query here, where I'm querying for a trip and the start time and who it is assigned to, we don't really need to know where the data is coming from at all. And it actually so happens in this query that we are looking at right here, the start time and the status of the trip itself, those are coming from the trip service. And that is perfect. Knowing the start time of a trip, the status of a trip, this is all in scope for the trip service. But a client might also need to know who the trip is assigned to. That is the name of the runner assigned to the trip. And that is rather dubious to be in scope for the trip service, we found. It would have required us to be aware of a whole bunch of information about the employee, and the employees are, employees are not trips. So what this query there actually does is to contact the HR system that we have behind the scenes. And this is just to tie together with an ID, which I did not even show here. So a client can just request whatever they want, get whatever they requested back without ever having to know that, in fact, this information is spread all over a cluster, which is, again, exactly what we wanted. So this didn't come entirely for free. We needed to make some technology choices to make it actually happen. But just to give a few examples of the kind of decisions we had to make, I can mention the GraphQL implementation. So GraphQL itself is basically just a language, but we also need to choose an implementation. And there are quite a few of them around. I believe we will be hearing about an interesting one in the next talk. But the one we chose was Apollo. It is a very popular one. So as Java developers tend to laugh about, we chose JavaScript because it was mature and stable. We actually ended up augmenting it with TypeScript so that we maintain our own sanity. But one of the more interesting things that came out of this, so basically chose it because it had huge adoption, but also something that I thought was nice at first, but turned out to be absolutely fantastic. That is that the skill set of the whole team actually applied when building this GraphQL backend service. So we had Java backend developers. We had front-end developers using TypeScript in the React Native application. And building this service really brought the whole team together. And on one hand, that's because GraphQL is the natural interface for front end and back end, but in this case also just based on actual implementation. So yeah, this really changed quite a few conversations. It's not just anymore about okay, I write an endpoint, then you call the endpoint, or okay, I need this data, please write an endpoint. It's we come together and we decide what information needs to go into the GraphQL schema, and I really like the results. Another thing, we needed to somehow push this into our existing deployment. So great big trick here. What we did was to use a proxy. As mentioned earlier, we were already using a proxy for authentication, so we were already experienced with using proxies. So what we did, and what we placed in front of the trip service, which originally had everything, we created a gateway service. We directed all of the requests for the original API to the trip service. And if the request started with /GraphQL, then it is taken over by the GraphQL server. And the GraphQL server directs traffic towards whatever application actually is required. And yeah, this just worked. We plugged it in, and the proxies that we put in place, they just did their job. And at this point, this is a perfectly serviceable structure for the deployment for, I think, a very long time. There is very limited motivation to actually move the features we had already written in the trip service and take them into the GraphQL realm. I mean, they are stable, they are mature, and nobody is asking us to change it. But at this point, most of our new development is taking place in the GraphQL realm. And it has the very fantastic advantage of just automatically aggregating data across microservices. And another thing that we decided to do is that we did not end up embedding GraphQL very deeply into the clients. So what we did in the clients, we basically abstracted the GraphQL calls with a service interface and just treated the GraphQL service like any other source of network calls. Because as we saw, the response from a GraphQL server is just JSON, and we can treat it as such. So this did limit us on the depth of the integration, because GraphQL can do all kinds of things I have seen in other applications, like substantially reducing the need for dedicated state storage or caching and all kinds of things like that. There are dedicated GraphQL clients which can do that. We decided not to do that and just focus on getting the data into the client. And this has made it a lot easier to just adopt our existing React components, be that in React Native or in React itself. But yeah, I think that leaves a very small question on where to. So everything I talked about so far has been about GraphQL in Picnic in the runner app team, which raises the question of what to do next. But at this point, I would say that I can tell you that there is a high degree of satisfaction within the team. And this talk actually comes at a very interesting time for us, because as far as I'm concerned, this is the time to decide that GraphQL is good and we should start using it more. And I think we consider this talk as part of my evangelism within the company. Yes, we have been doing some nice work, and I think we should adopt it in more places. And the next thing I will do is to push it forward on our internal company tech radar. So yeah, so currently this technology is in trial, but I think we are ready to see more of it. Yes, this was it from me, and I will now be happy to take questions.
All right, great. Thanks, Ernir. So one thing I learned is that GraphQL is amazing, not magical. So that's a nice takeaway. But there are some questions indeed. So let's go over those. The first one is being a SQL developer, I'm worried about one thing. Can GraphQL replace SQL? People debate a lot on this. So maybe you can give your thoughts on the relation between GraphQL as a query language and SQL as a database query language.
Yes, so I would not see it like this. But what SQL and GraphQL have in common is that they are query language indeed, but GraphQL is very so. If you read about GraphQL, it is all the wording is very general. It is not very much talking about HTTP and GraphQL over APIs or something like that. But in practice, GraphQL is basically always about alternatives to REST APIs. It is GraphQL over HTTP. And there, I don't really see much in the way of competition between GraphQL and SQL. So I don't think SQL is going anywhere. We might see some adoption of GraphQL in more, well, in the places where we normally don't see REST APIs, like where we don't really see much in the way of SQL, like for abstraction over MongoDB, where we have a large collection of data and just need some rather simple mechanism for that. But in my mind, these are rather different. And yeah, SQL is not going anywhere. It hasn't gone anywhere for what, 50 years now?
In fact, I believe a lot of the data that is going through the GraphQL API for the runner app comes from a SQL database, right?
Yes, yes. All of the microservices that the runner app team maintains are actually backed by Postgres databases.
Yeah. All right, great. So the next question is, are there any plans for you to create a public GraphQL API?
Plans for a public GraphQL API? At this point, there are no plans, but I am certainly excited by the possibility. There are huge questions, particularly about data security, but in practice, this should be possible. And in fact, I think that if Picnic goes into the direction of creating more open and public APIs, I think GraphQL is a very interesting approach to take, because what we can do with GraphQL, I did not spend a lot of time talking about security, but when we have GraphQL, the problem moves kind of from securing individual endpoints to securing certain pieces of technology. Mm-hmm. And yeah, I hope it can, but no, we have no plans to do that at this point.
All right. So the next question is, while data aggregation from multiple systems is how should we handle a scenario where one of the systems is very slow? Would it affect the overall performance?
That would affect the overall performance. I actually have not looked into strategies for expecting different service levels from different services. Mm-hmm. I am mostly interacting with services that are maintained within the company, which makes this problem a lot easier. But what I would expect to happen is that you would need to deal with this on the data source level. So each service can then service an individual data source with its own failure policies, basically. And also what you can do in GraphQL, you can specify whether a field is actually required as part of a response or not. Mm-hmm. So you can mark a field as non-nullable or required in the GraphQL schema, and then the whole query will fail if the underlying data source fails. But you can also specify that, okay, if some data is missing, then it will simply be missing in the response. So it can be dealt with, but yeah, I don't think GraphQL necessarily make this problem any more pleasant than otherwise.
There's still no magic there. Yeah.
Nope.
So one last question, and there are still a few more, but maybe you can take those offline. The last question I wanted to ask is around, let's see, where is it? Resolvers. Yeah. So in your team, whose responsibility is it, backend or front end, to write resolvers in your GraphQL layer in case you need more functionality?
Yeah. So resolvers, those are, well, there are a bunch of ways to get default resolvers. Those are easy, but I guess the question is about those resolvers which really need a lot of thought. If it is complicated, if it is something that is likely to be performance critical, we have had the backend developers do it. But that being said, in general, writing resolvers, yeah, the front endies have really taken to it. That has not really been a problem. And the problems that we have observed with connecting everything together, it has actually had nothing to do with GraphQL. So yeah, it is backendies when it's tricky, but yeah, frontendies have been fully able to do it as well.
All right, thanks a lot, Anir, and great to have you here with your talk.
Thank you.
Let's move on to Paul and
Yes.
hear about Netflix DGS.
Thanks again.
All right.
What do you?
All right, let's do it. See if I can share my screen. There we are. All right, so we're going to talk about the DGS framework and look at how Netflix is using that. So the DGS framework stands for Domain Graph Service Framework. That's kind of a fancy name we came up at Netflix when we first got started with GraphQL. A DGS was a microservice with a GraphQL API, essentially. Fast forward more than a year later, we decided to open source the framework, and this DGS name was kind of spread all over the code and package names and all that, and we decided to just keep it. So that is where the name DGS framework comes from. Don't read into it too much. Right. So in this talk, I'm going to talk a little bit about why you should consider GraphQL and most specifically how it's different from REST. Over that pretty quickly. Talk a little bit about the DGS framework history at Netflix and how we use it. And then primarily, we're just going to look at a framework and kind of get a feel of how you would build a GraphQL API using this framework. And that will kind of show how we are using it in practice as well. So my name is Paul. I am originally from the Netherlands, but I've been in California, Los Gatos for the last 4 years. I work for Netflix. I'm in the productivity engineering team, which means we build tools, frameworks, and all that to make our own developers more efficient. And for the last 18 months or so, I've been super focused on GraphQL, which we started adopting around that time. And I've been working on the DGS framework. I published 2 books, both about Java modularity. One of those together with Sander, who you all know. So yeah, that's about me. I'm also a Java champion. Right, so let's take a little bit of a look at the GraphQL basics, and especially compare it a little bit with REST, and look at how it's different and why that might be better. So the first thing you should know about GraphQL is that you always have a schema. The schema is the central thing for any GraphQL API. And every GraphQL schema has 3 basic types: a query, mutation, and subscriptions. The query type is basically defining what data you can get from from the API. Mutations is about sending data to the server, which is like updating data. And subscriptions is it's basically a streaming version of queries where you can get live updates. And this is often used in combination with something like WebSockets or service and events. Today, we're primarily going to look at queries, but the implementing a mutation or subscription is pretty much the same if you would be looking at a code. So let's take a look at an example schema. So in this case, we are defining our query, and our query only has one field. So we have the shows query here. And the shows query returns an array or a list of show. Show is obviously a custom type, so we define a show type as well, and it's defined as having a title of type string, and it also has reviews, which is a list of reviews. And again, reviews is a custom type, so we define the review type, and a review has a submitted by, which is a string, which would be like a username or something like that, and a rating, which is defined as an integer. So we see a few kind of core types of GraphQL, like string and int. They are very comparable to like primitives that we have in a language like Java. But it's also super easy to define your own types. So if we have this schema in place, we can now think about queries. And on the right-hand side of the slide, we have an example query using this schema. So in this case, we are asking for the title of shows. And this would give us the title of each show, typically. So the interesting thing here is that we're only asking for the title field. We are not asking for the review fields. And if you would execute this query, that's exactly what you get. So we get back a JSON result. And in there, we have a list of shows, and we only get a title. And this is the first example that we see of field selection or projection, as we also call it. You only get the data that you're explicitly asking for. So if we now move forward and extend the query a little bit, now the query also contains reviews. So the first thing to know about this is that if I want to get review data, I have to specifically say what fields of a review I want to get. So in this case, I'm asking for both the star score and the submitted date. If I would omit the field selection for a review, it would be an invalid query. So I can't say, give me all the data you have from a review. I have to be specific about each and every field that I want to get back from my query. For people coming from a REST world, that might be surprising, because in the REST world, you're basically just, you're asking for data, and the server decides what data you're getting back. You don't have much control over that. That is a problem, but it's also convenient in some cases, because you can just, you do that one query, you don't have to specify what data you want. And in GraphQL, you always have to do that, but that's actually a huge benefit. So if you would execute this query, now we're getting the review data as well. So if we would kind of face it off with REST a little bit, the biggest difference between GraphQL and REST is that GraphQL has a schema and REST obviously doesn't. And that's where all the power of GraphQL is really coming from, the fact that we have a schema. Because we have that schema, obviously the API is sort of self-documenting. So we don't have to have extra tooling in place to write documentation about our API. Someone can just look at a schema and figure out what data is available. But a schema also gives us the possibility to do that field projection, which is also a requirement. And this field projection, so choosing which fields you want to get back from a query, is super important, because that avoids the problem of overfetching. With a REST API, you write one REST API, and the REST API will be serving data to all the different clients and devices that you have. Well, think about the Netflix app that you use as a consumer for a moment. There's iOS that we support, there's Android, there's TVs, many different types of TVs, there's Xbox, PlayStation, etc., etc. There's like an endless list of devices that we support. Each device has a similar but different interface. So, for example, if you would compare iOS and Android, the way the screens are built are slightly different. And that means that to build those screens, you need slightly different data from the backend at different points in time. So it would be very inefficient if we would just dump all the data that we have about the shows that you get in your list of movies, or what we call a LOLMO, the list of movies. If you would just dump all the data to the devices, these applications would just not be efficient, and we couldn't optimize it the way that we're doing it. So what we do in practice when we were still on the REST API is we basically had to write a REST API for each and every device. So we don't have one REST API, but we have as many REST APIs as we have devices, which is much harder to maintain. And that's often called the BFF pattern, the best. No, not the best. It's the backend for front-end pattern. So we avoid this whole problem, and we avoid the need for a BFF with field projection, and that really sets GraphQL apart. Another difference is that we typically only have one HTTP endpoint with GraphQL. Typically, you only have /GraphQL on your service, while with a true REST API, of course, you have the different HTTP verbs, and you have different endpoints basically for different parts of the data that you are retrieving. Either technology though can be used with any HTTP client. Typically, GraphQL is just used over HTTP. That's not required by the spec, but it's pretty much how everyone is using it. And that means you can use any HTTP client to successfully work with a GraphQL endpoint. But on top of that, because there's a schema, there's also kind of more intelligent clients, such as Apollo client, which makes it much easier to build an efficient front end. So that's quite nice as well. But the main thing here is really that there is a schema. So let's take a little bit of a look at how Netflix got started with GraphQL and how this all became an open source project. So about a year and a half ago, we were very rapidly building what we call the studio space at a company. And the studio space is basically the movie studios that Netflix has. As you might or might not know, Netflix is actually one of the largest movie studios in the world. And that means there's lots of productions going on at every given time. And every production involves many, many people. And to kind of keep track of everything, we have a lot of custom built applications. And there's several hundreds of applications that we are using that are all built internally to kind of manage the studio space. So it's kind of the other side of the business than what you see as a consumer, but it's a really big area. So because we have these hundreds of apps in the studio space, these apps all need data, obviously. And what we previously had is basically hundreds of microservices that would all just serve the data for the UI they were serving data to. And there was a lot of duplication in the data. So we had a lot of different representations of a movie, for example. And data duplication, of course, has its problems. So at some point, we wanted to consolidate that and have a one API that all these different apps and devices could use. And GraphQL was kind of the obvious choice there. After a little while, we started to get into GraphQL Federation, which is a super interesting topic and a really good way to get a composed schema, basically, from different microservices that all provide parts of the schema. I'm not going into that because that's just a whole talk by itself. But around the time that we started getting into GraphQL Federation, what it meant for our backend teams is that our backend teams that were all doing Java microservices, they now all had to onboard on GraphQL to be part of this new architecture. And we need to do that pretty quickly and onboard about 100 teams in the year ahead. And onboarding 100 teams on a completely new technology is obviously not easy. So we needed to have a really good developer experience for those teams to successfully get started with GraphQL. So that's where we started looking at what can we do in the Java ecosystem to build GraphQL services. Well, the super important library that is available in open source for Java is GraphQL Java, and that's what we built on top. But GraphQL Java is a fairly low-level library. It is super powerful, but not extremely easy to use just as a developer implementing a service. And that's great because it's not designed to be that. It's designed to be a common library, basically. So what we decided is to build on top of our, what we call the paved path that we have at Netflix, which is standardized on Java and Spring Boot. And we have lots of tools and libraries built internally on top of Spring Boot internally. But we decided to build GraphQL a GraphQL implementation for Spring Boot specifically. And that is what is today the DGS framework. So originally, we kind of envisioned this framework to be just something internal, something that was super Netflix specific, and it would just integrate with our internal systems for like tracing and logging and metrics, which is all super important if you run at scale. And we kind of envisioned this framework to just be a Netflix specific implementation. But after about a year, we kind of learned that primarily what we had built was just a great way to do GraphQL in Spring Boot. And that's when we started thinking, well, this is actually something that a lot of other people could benefit from. And that's when we decided to open source, which happened earlier this year. So this open source project is fairly new. It's only about a month ago that we open sourced it, but it's exactly the code that we've been working on for the last 18 months or so. And we've obviously been running this at scale, and it's used internally by about 100 teams now at Netflix. So let's take a look at actually building a DGS. And as I mentioned, it is all built on top of Spring Boot, so that is kind of the core requirement. So what I'm going to do is switch to IntelliJ, and we're just going to set up a new project here. And I'm going to use the Spring initializer so that you just get a new Spring project. We're going to use Gradle. We're using Java because most folks are probably more familiar with that. And that's it. So we have our empty Spring project here. And of course, now we need to add the DGS framework to that. As we see, we just have the Spring Boot starter, nothing else there yet. So I'm just going to open a browser and we're going to go to the DGS website. So this is our documentation. And we're just copy pasting this dependency, which is another Spring Boot starter, which adds the DGS stack to our application. And the other thing that I want is code generation, and we'll see how we use that, which is a plugin that we have. It is completely optional, but it's very convenient to use. And the plugin needs a little bit of configuration, which I'll just copy in here, and we should be good to go. So let's refresh this project and we can start building something. If I write this correctly. So there we go. So we have an empty Spring Boot application with the DGS framework installed, and we have code generation set up. That's it. Now we actually have to start writing a GraphQL API. So the first thing that we have to do when building a GraphQL API is create a schema. So we really encourage to do schema first development, as we call it, which means you write your schema by hand. You take your time to actually design and think about your schema. And that's a super important step because that is what is shaping your API. And after you create your schema, then you start implementing it in Java. There's a few frameworks available in different languages that do the opposite. So you generate a schema from code. The downside of that is that you have it's not an obvious step where you're designing the schema. And it's much easier to, for example, introduce breaking changes to a schema, which is something you just really want to avoid. So although that approach is also supported by the DGS framework, if you really want it, we really recommend using a schema first approach. So we're just going to create a new schema file in the schema directory. And here we are going to create a schema very similar to what we showed on slides earlier. So we have a type query. We will return shows, and I'm going to introduce a parameter to this query as well, just a title filter. We'll get back to that later. And this query is going to return a list of show. Now we also have to define the show type. So show has a title and a rating. Keep it pretty simple. And now I just want to implement this schema using the DGS framework. So the first thing that we need is a so-called data fetcher. So we need a data fetcher that basically gives us data whenever this show query is received. So we create a new Java class, which we call the show data fetcher. And we annotate this this class with DGS component. So this is very similar to just using an add component in Spring, but it tells the DGS framework that it is a component that is part of the DGS framework. And we are writing a method that we are annotating with @DGSData, which says this method that we're going to write is a data fetcher. And it's a data fetcher for a specific type and a specific field. So going back to our schema, the type that we have here is the query, and the field is show. The parent type will be query, and we can use code generation for the first time here. We use a generated class. If I actually run code generation, we run Gradle, which generates some Java code based on the schema. And once that's done, I should have a, actually it's not done. So this generates Java types for our schema defined types, and we will use those. And it also generates a constants class, but basically just references to all the types and the fields in the schema. So it did generate all this code now. And the first thing that we use is this DGS constants class that was generated, where this is really just constants based on the schema types that we have. So we use DGSData. Parent type is DGS constants.query type, and the field is DGS constants.query.show. Right, so now we actually have to write a method, which is going to be a public list of show. And I'm ignoring my query argument for this moment. And we just need basically a list of shows. So this is where I would typically go to either a gRPC service that we're calling in the backend, or maybe load data from a database. It doesn't really matter where it's coming from. But for this example, we're just going to create a in-memory list right here. This is show data. This is a list of shows. And again, we're going to use the generated types here. So what we got from code generation is a builder style API to create our GraphQL types. So we see that we have this show type with a title, and let's say we have Ozark, a pretty good show. and I give that a 5 rating. And let's add one more. Oops. It's going to be Stranger Things, which I'm also rating 5. And we're building that. So that's our data. And from our data fetcher, we can simply just return this. So our data fetcher can just return Java types, basically. The Java type does have to match with whatever we have defined in our schema. But from a code perspective, it's really just quite easy what we're doing here. Right, so we're ready to start and test this application. So let's just run it as a regular Spring Boot application. And once it's started, you can open a browser and go localhost 8080 GraphQL. So you get this out of the box with the DGS framework. It's basically just a query editor. And we can use code completion here, which explores the schema. And it tells us that we have shows, and a show has a title and a rating. So that's our query. We can run it, and we get the data back from our newly implemented GraphQL service. Right, so that was the simplest case possible. Of course, I did have this title filter here that I just literally ignored. So let's try to implement that as well. So we can get query arguments in our data fetchers by using another annotation, which is an input argument. And it's going to be of type string, and it's called title filter. And based on this title filter, I can check if it's set or not, because it's optional. So a type in GraphQL defined like this means it's an optional parameter. If I don't want it to be optional, I could make it look like this. But typically, we just keep things optional. So if it's not null, we're going to filter our list of shows. And look at the title, and if it starts with our title filter, we're going to return it. That's it. So let's restart the application. And if you run it again, this should still happily work. But we can now also pass in our title filter. And let's say that we just want to have title starting with OZ, and we just get Ozark. So that's pretty good. So you see, you can fairly easily just create these types of APIs. So one more thing I want to show in the framework, and that's testing, which is a pretty nice feature. So let's say that we actually want to test this code and not just test it by hand. We can generate a test class. And what we're doing in this test class is making it a Spring Boot test. And we are going to specifically only bootstrap the DGS framework and our data fetching code. So the nice thing about being specific about which clusters we bootstrap is that if you have a larger application that integrates with databases and other services and whatnot, it can take longer to bootstrap an application, as we probably all know. That is not a problem for your tests here. These tests will, if you define them like this, will always run in like under half a second, which is pretty good. And this being a Spring Boot test now, we can simply auto-wire a DGS query executor. And we can start writing our test, sort of just like a unit test. With filter. So let's create a query first. So we have our query here, and I'm just going to copy the query from the browser. And this looks terrible. This is something that is just not very nice in Java because we don't have multi-line strings. It would be a lot nicer in a newer Java version or Kotlin. But I will also get back to this because we actually have a nicer alternative for this. But let's first try to get a test working. So we use the query executor to execute this query. And this goes through all the normal framework code, but it doesn't require HTTP. So this goes directly into the query executor internally used by your real DGS service as well. And the second argument of this is a JSON pod, and that basically allows us to peek out just titles from the show. I call it show, not shows. And that's going to be our titles, which is a list of string. And now we can just write an assert which says titles contains exactly Ozark, because we were filtering for that specifically. And we can just run it as a normal unit test. So that's successful. Well, you should always be suspicious of anything that doesn't fail first. So I'm actually going to break this code, introduce a bug, rerun my test, and see if it actually catches this bug. And it does, and it tells me exactly that I'm getting more data than I expected, which is obviously a bug. And then the very last thing that I want to show here is that this is obviously not a great way to build your queries in Java. So we have a better mechanism for that, which is also based on code generation, which is we can create a DGS query request, sorry, a GraphQL query request, which takes two arguments, a query and a projection. The query is generated, so this is going to be a show query, which is again a builder. You can pass in our title filter. And the second argument to a GraphQL query request is a projection. So that's basically telling it what fields we expect to get back. And that is a show projection. And here again, we get, based on our schema, the fields that are available. And as you can see, this makes it much easier to actually build, programmatically build a query in Java. And based on this, we can just create a query again, which is the serialized version of this string. And it should just give us exactly the same result as that we previously had. But now we don't have this string concatenation going on, which is quite powerful. You can use the same mechanisms if you want to build a Java client for a GraphQL API, which is another very powerful way of doing things. Right, so this gives at least a little bit of an idea of how this framework works. There's a lot more you can do with it. We have seen how the programming model works. Obviously, there's a lot more features to it. We have seen a little bit of code generation, which is pretty nice. Again, it's completely optional. If you really don't like code generation, you don't have to use it. The framework integrates really well with GraphQL Federation because that's the architecture that we're using at scale at Netflix. Federation is a fairly new spec in the GraphQL world. Apollo introduced that probably about 2 years ago, and Netflix is actually collaborating with Apollo quite a bit on this spec as well. The framework integrates with Spring Security, so you can just add an add secured on your data fetcher. You get field level security or OutZ. We support subscriptions over WebSockets and server-side events, file uploads, all sorts of error handling that you can add. Support for things like interfaces and unions in a very convenient way to write. Again, all kind of annotation based. There's a GraphQL client for Java. There's lots of ways to plug in instrumentation for like distributed tracing and all that. And very recently, just a few days ago, we had a release that also introduces micrometer to the framework. We already used that internally at Netflix, but that's now also part of open source. So you get metrics for free, basically. And there's a lot more stuff to it. It's pretty much being extended all the time, the framework. I guess that's pretty much all we have for time as well. So let's get to questions.
All right, great. Thanks, Paul. Really cool to see what you did there with the team at Netflix. There are indeed a few questions, so let's take a few. First one is, do you always have to create a static schema file, or is it possible to generate one from Java dynamically?
It is definitely possible to generate it dynamically. We have all the hooks for that in the framework. We have a few teams using this extensively at Netflix. They already had a schema defined basically, which was already graph style, basically. It wasn't GraphQL, but it was the same style of API, and that was very easy to basically just generate. Mm-hmm. However, in general, for like 90% of the use cases, we strongly recommend going the schema first approach, because it will, in the end, give you a better API, and it will it's also a really helpful mechanism to work on the schema between the backend and front-end teams, for example. If you don't have that static schema, that suddenly becomes a little bit harder.
Yeah. And just to follow up on that, if you do have a schema that you define up front, you showed that you have some code generation that you can apply there. What if you don't want to use the code generation? Can you bring your own domain classes? And is there any verification then going on against the schema, or how does that work?
You don't get verification at build time in that case, but you can just use whatever Java type you bring, basically. So if you already have, I don't know, maybe entity classes using something like JPA or whatever, you can definitely just use those. If you just want to write them specifically yourself, that's a good option. The only thing the code gen is doing two things. It creates those POJOs with builder style APIs, and it creates those query APIs. And these are the two distinct parts of what CodeGen does. You don't have to use any of them.
Mm-hmm. Okay, that makes sense. There's also a question about federation. How do you handle the API gateway responsible for federating? Because it basically has a dependency on all underlying services. Do the teams maintain the service, and maintaining the services also maintain the gateway, or how does it work at Netflix?
So we have a specific team that builds and runs the gateway. So if a custom implementation of the gateway, we are not using the Apollo's tools, for example. It is very much modeled to what Apollo has as well, but we just really needed to fit it better in our ecosystem with all the tracing and metrics and things that we have. That's why we built a custom implementation. It's based on Kotlin. It is just implementing the spec. One important aspect of that gateway is that the gateway is as dumb as possible. So it's really efficient at executing queries, but it shouldn't have any knowledge of the actual services that you're talking to. It doesn't have explicit references to any of these services. That's all just managed in a service registry, basically, and done dynamically. Go ahead.
It's just infrastructure, we'll say.
It's really just infrastructure. Yeah. That means that the microservices teams that implement the DGS, they are responsible for registering their service to the service registry, which means they have to register their schema, and then it just kind of just all works.
Yeah. All right, so indeed we're nearing the end of our time. So one last question I would like to pose on behalf of the audience. Are there any special requirements on your infrastructure when you want to use GraphQL in terms of service, networking, configuration, etc.?
No.
No.
I'm trying to think of something.
Yeah.
It's not fair, not a great answer, I guess, but I would say if you can successfully run REST today, it's just as easy to do GraphQL.
Yeah, indeed. All right. Thanks a lot, Paul. Thanks a lot, Annie, as well. I think we had a great overview of GraphQL, both at the Picnic and at Netflix. Really cool to see. I think we'll be hearing more about the GGS library going forward. And I've seen a lot of really nice articles about it already in various publications. So good job on the promotion as well, Paul, with the team.
Thanks.
And good luck with further development. So thanks everyone for joining this meetup. There will be more, so definitely keep an eye on our meetup page. This will be recorded, as I said. It will be published on YouTube. We'll publish the link on the meetup as well, so that you can share and rewatch if you want to. And again, if you enjoy this kind of content, also consider visiting our blog at blog.picnic.nl. And I hope to see you at a future meetup. Thanks everyone, and until next time. Bye-bye.
See ya.
Thank you. Bye.